And then the final piece of code I want to show you is, I showed you in this diagram that the entity, created these events and stored these events, but these events aren't very queryable. So in order to make this data queryable, there's this process of going from this write side to a read side. But this is happening in the background. It's not happening within the same transaction that occurred to write the event to the database, which is very quick, very minimal transaction. So in the background, what's happening is there's something running, it's called an event handler, that's taking those events as fast as possible and projecting that data into some kind of queryable views, queryable tables. So that's what's happening next. Then the data here is then stored in a way that's optimal for the kinds of queries that this service needs to perform. So that's what, the red arrow pointing at the read side here is what we're looking at. And just to kind of hopefully help with this, because I know often this is a pretty new concept, got another diagram here that I'm trying to get this point across, is that, I got these phones, devices that are sending in commands, this is kind of over time, and it's not in any way implying rate, it's just implying that there's a stream, think of a device as sending a stream of commands into your application. So these commands are flowing in from whatever the users of the device, bang on the glass on the screen to make something happen. But they're being processed by these command handlers, these entities, and then the processing, as we've talked about, results in events. And I just think of an event store as this kind of never-ending stack of events, one event piled on top of the other. It's just this simple, very simple key value data store. So that's the processing flow. And the big thing here is the command comes in, it gets processed, the event gets stored, and we go back to the user. So we go back to the client doing the least amount of work is kind of the idea here. So we can get, we have fast response to the client even under heavy loads. But then behind the scenes, I'm going to kind of zoom in here, are running in the background. In general, there are these things, they're event handlers. So these event handlers are reading by offset. Each one is running independently. Outside the transaction where the events were created, that's an important point, but they're reading as fast as possible from the new events as they're added. And they're doing something with these events. So I've got 3 examples here. One example is these events are being pushed, one event handler here is pushing messages out to a message bus. Another event handler maybe is doing what I'm talking about right now, which is taking events and making them queryable, doing some kind of processing to update tables and whatever in some kind of a database. And a third event handler, just for the sake of an example, say is pushing the same events out to some kind of external API. So these event handlers could be doing filtering and manipulation and processing, whatever. Each one of these are different. But also more importantly is things like, say this external service is offline for some reason. We can't talk to it right now. But the users are still, busily adding, sending in commands, which are producing events. So the microservice itself is still servicing the users. It's still working is the main point, regardless of the fact that say this external service is offline at the moment. Well, that's no big deal because these event handlers are built in a way where when they can't do their work, it's kind of a circuit breaker type of implementation where they'll back off, but they'll keep occasionally retrying to perform the operation they're supposed to try. So when this external service comes back online, the event handler picks up where it left off, and maybe now it has a backlog to work through, but it'll work through it as quickly as possible. So this gives you a form of reliability as well as performance, because the users aren't paying for this overhead. This is stuff happening behind the scenes. So it's another feature of trying to build highly performant